Okay, so I want to talk about valuing a callable bond, and there are going to be basically 3 steps to that. First, we're going to have to build out what I'll call the interest rate tree. Secondly, this is really 3 steps. Secondly, we can value a non-callable, and we can value that non-callable just to make sure we have the tree right, but we don't absolutely have to do it. And third, we value the callable. And it doesn't even have to be a callable. It can be any type of option, puttable, any type of embedded option. So those are the 3 things we need to do. We start with this given information, and then we bootstrap the spot rate curve, which you should remember how to do. So we're saying the market value. In this case, by the way, to make it simple, I'm assuming annual compounding. Alright, it's a good spelling of compounding. So what I'm doing here is saying 100 is equal to, and this is going to have a coupon rate of 3.5. So the price 100 is equal to 100 plus 3.5 divided by 1 plus R. R is equal to 3.5%. And you continue like that. Okay, so let's get rid of that portion of it. Now that we have that, we can value this a new bond, and I'm going to say the new bond has a 6% coupon. And the traditional way to value that, the price is equal to 6 over the 1.035 plus 6 over this right here, 1.0401 squared plus 106 over 1.04531 cubed. So that's what we've done in the past. What we want to do now is build out this binomial tree and make sure that when we value the bond the traditional way like this, we get the same value or close. There could be some rounding problems that we will get when we have this binomial tree. So first, we start with an assumption that will be given to you about the volatility of interest rates, and let's say that it's 10%. So here's the plan that we're looking at. We're saying there is, I already know the 1-year rate. They call this the root rate of the tree, so I already know that. So this is time 0, this is time 1, and over here this is time 2. So if I buy a 2-year bond, it's going to pay me 100 plus a coupon. So this C stands for coupon, the V stands for value. So the value of the bond when it matures is 100% par plus you get the coupon. And no matter what happens, that's going to be the case. And the way this binomial tree works is we have an interest rate today at 3.5%, and we know the interest rate can either go up or it can go down. And then when it goes up here, it can either go up or it can go down, it can go up or it could go down. But we're really just concerned about these 2 rates for now. We'll be concerned about these rates in the next step. So what am I saying? We're just ignoring a bunch of the foundational math to it and the proof of it, just skipping how to implement the thing. We'll say this value, the price right there, the price at time 1 H, I should really say V to be consistent, the value at time 1 H, H is if we have the high rate versus L if we have the low rate, is equal to, we'll say we have a 50% chance that the bond price goes up to where it's worth 100, plus you get the $4 coupon, but that comes 1 year from now, and the current interest rate is 1 plus, we'll call this R1H. So right now we don't know this number. So let me cross this out. Right now we don't know that number. And then this will be 50% chance, 100 plus 4 divided by 1 plus R1H. So in other words, this value comes from the present value of this payoff and there's a 50% chance of it, plus a 50% chance of the present value of this payoff, and I'm valuing it right now at a rate that I'm not sure of. Same thing down here. The value at time 1 low, if interest rates go low, is 50% chance of 100 plus 4 over 1 plus R1L, plus 50% chance of 100 plus 4 over 1 plus R1L. So then I find those values. And once I have those values, and I happen to know they're 99.071 and 99.929, but once again, I don't know these rates quite yet, where I get those rates. Well, the value today, this value, V0, has to equal, there's a 1/2 chance it goes up to be worth V1H. And if it's worth V1H right here, you divide that by 1.035. I know this because this interest rate is the root rate of the tree, which I've determined right here. Plus there's a 50% chance of the value going down, where it would be this value, and divide that by 1.035. And I know that that's equal to 100. I know it's equal to 100 because the market value of this 2-year bond is 100. Alright, so here's what you can't do in the classroom without Excel, which you don't have. I know I need to guess this interest rate. I know, once again, and we won't go through the proof of this, the interest rate in one period, the high interest rate is equal to the low interest rate times e to the 2 sigma. So this is just something, and we can talk in more detail about this if you want to, but just for the mechanics of it, I know the relationship of this interest rate and that interest rate. I just don't know what they are. So once again, let me review what I know. I know 3.5%. I know the relationship of this interest rate to that one. I just don't know what's inside them. I know the values are given by these equations. I know the value, if the interest rates go up 1 year from now, is going to be given by this equation. I just don't know what it's going to be equal to. I know the value if interest rates go down is equal to that equation. I know the value today is equal to this equation, and I know that's equal to 100. So what I have to do is guess this number. I guess this interest rate, and I guess it to be 4.074%. And if that's 4.074%, R1H is equal to 0.04074 e to the 2 times 0.1, which is e to the 0.2, which is equal to this number right here, which I've covered up, is like 4.976%. If that's true, if this is true, the 4.074 is true, that's 99.29, that's 99.071. And if that's true, I work back and this is equal to 100. So Excel has a solver that does that for me. So let's look through same type setup, just doing it again. Look over here. Now I know this rate because this is the root rate of the tree. I found it from right here. Rates could go down or they could go up. And I've determined that they could go down to 407 or up to 4.97. I know that because if that's true over here, it gives this value if rates go down, this value if rates go up, which gets me back to this value, which is the price of the 2-year bond. So now I'm looking at the 3-year bond, and the 3-year bond, I'll change colors for the 3-year bond, has a 4.5% coupon, so the coupon it pays is 4.5 everywhere, right? It's going to pay excuse me, a coupon of 4.5 in year 1, in year 2, and in year 3. Alright, the number that I need to find is this value, because whatever this value is, this is equal to R2LL, well, let me just write it this way. Wherever this is, you multiply by E to the 2 sigma, and you get that number. This E to the 4 sigma. So this times E to the 2 sigma is that. This times E to the 4 sigma is this. So what I have to do is guess an interest rate here that makes the value come back to be 100, which is the value of the 3-year bond. The Excel solver didn't get me one that was exact. It got one that was really, really close. But we're not worried about making Excel solver work right. We're just worried about the mechanics of it. So the way this is worked out, once again, the value here, this 9972, the value times 2, if we go down and go down, is equal to 104.5 over 1.04529. This value, the value, this one right here, the value in 1 year if rates go down is equal to a half of the chance that rates go up to 99.022. So if rates go to this point, there's the value, plus I get the 4.5% coupon, divide that by 1.04074, plus there's a 50% chance that it goes down, the value, interest rates go down, so the value goes to 99.972, plus I get my 4.5% coupon, divide that by 1.0474. That gives me this value. Once again, choosing this one changes these rates change these values. With those new values, I have new values here, which a new value here, so I got to pick this number so that this is equal to 100. Excel solver does that for me. Supposedly doesn't do it perfectly, but now I have the rate tree built out. So now I can look at this. I can say my interest rate today is 3.5. In 1 year, it's either going to be 4.9 or 4.0. In 2 years, it's going to be 4.529, 5.532, or 6.757. Now that I have those interest rates, I can value any bond. So let me put another Excel spreadsheet up here. Give me just a second. Okay, so what I have here is a 6% coupon bond that matures in 3 years, but it has call features. It's callable at 104 in a year and callable at 104 in 2 years. So I know that interest rates right now are 3.5%. I know they can either go up to 4.976 or go down, and if they went up, they could go up again, or they could go down. If they went down, they could go up, or they could go down. So I've built out my interest rate tree. Then I look at the value of the bond. If it goes all the way to maturity, it's going to be worth 100% of par and pay the 6% coupon. So no matter what happens to interest rates, rates could go down, down, and down. They could go down, down, and up, down, up, and down, up, and up, whatever. It's always going to be this value. So as I go back through the tree, this 99.291 is a 50% chance of getting this payoff discounted at this interest rate, plus a 50% chance of that payoff discounted at that interest rate. This 100.85 is a 50% chance. Just let me write that out. The 100, and actually let me do this so I can make this easier to deal with. This value, this 100.850 is equal to a 50% chance that we have 99.291, the value of interest rates go up, plus a 6% excuse me, coupon. Divide that by 1.04976, plus the value of rates go down, 100.444 plus 6 over 1.04976. So that tells me this value. Alright, if the bond is callable, the issuer has the right to call the bond in and pay this amount in par value. This bond is never called because the value never gets above 104 in year 1. It never gets above 104 in year 2. So this value should give you the exact same value you would get if you did, the value of the bond is equal to 6 divided by 1 plus R1 plus 6 divided by 1 plus R2 squared plus 106 divided by 1.1 plus R3 cubed, where the spot rates that we had earlier in the presentation are substituting for R1, R2, and R3. So now that we have that, if we change this number and this number, say this one changes to 101 and this changes to 102, which is not unusual that the call premium would go down. If this changes to 101, what happens? If the price goes to right here where the issuer called in, no, it costs 99.29. The issuer can buy it for 101. They let it stay the same. Would they buy it for 101 here? No, the value is less than that. Would they buy it for 101 here? Yes. The price went above the call price. That won't happen. So we mark this out. This is not possible. If interest rates go down to this value, the actual price of the bond will be 101. So now when I calculate this value right here, it's based on the price going up to 100 or interest rates going up, the price going down to 100.444. If interest rates go down, the price doesn't go to here, it goes to 101. The price here is below 102, so that stays the same. The price here, this will either be, and because this number's changed, I'm not sure what this one will be, but the most it could be is 102. So the value we have right here is going to be equal to, take the present value of this and the present value of this, or 102, whichever one is smaller. That gives you the value of a callable bond. Now you would have the value of a callable bond versus the value of a non-callable. What do you think the difference is? Which one would you rather have? You'd rather have this one, because lowering these numbers makes this number lower. So the value of a non-callable bond is equal to the value of a callable bond plus the call premium. So by doing this, we can identify the value of that call option embedded in the bond. We have one further concept here. Let me just get this stuff off the page. The option adjusted spread. So we know the value of the bond today is equal to the coupon over 1 plus R, the coupon over 1 plus R2 squared, par plus coupon over 1 plus R3 cubed. So this is the value of a non-callable bond. If we look at the value of the callable bond, you can't do the discounting this way. You have to use a tree like this. The option adjusted spread says if I add some premium, P, I add P right there, P, wherever that premium is, if I add that premium in there, it makes the value of the callable bond the same here that is there. That is the option adjusted spread. Alright, we'll see you tomorrow night.